Welcome to Lecture 2.3, Multiplication Property of Equality. So our multiplication property of equality, in short, means what I multiply to one side of an equation, as long as I multiply the other side by that same value, I will not change the solution set. For a more formal way of saying it, if any three algebraic expressions A, B, and C, where C is not 0, if A equals B, then AC equals BC. So multiplying both sides of an equation by the same non-zero amount will not change the solution set. So suppose we want to solve the equation 5x equals 30. Then we can use our multiplication property of equality to multiply both sides by 1/5 to solve for x. Now, why did I choose 1/5? 5x, if I multiply by the reciprocal of the coefficient is the number that's in front of the variable. If I multiply by the reciprocal, I'm guaranteed to get one variable left. In this case, 5, if I multiply by 1/5, I get 1x. And that's the whole purpose, is I want to get to know what the value of 1x is worth. But if I do it to the left-hand side of the equation, I must multiply the right-hand side of the equation by 1/5 as well. So let's look at that problem. 5x equals 30. Multiplying both sides by 1/5. 1/5 times 5 is x. 1/5 times 30 is 30 over 5, which can reduce down to 6. So x equals 6. Let's try another problem. Let's solve for a when we have the problem negative a equals 24. So I'm going to multiply both sides. Negative 4a equals 24. I'm going to multiply both sides by a negative 1/4 and a negative 1/4. Because my coefficient for a is negative 4, my reciprocal of negative a is negative 1/4. So negative 1/4 multiplied by 4, and I'm just going to show you this step, equals 24/4. Negative 4 over negative 4 is 1. 4 goes into 24 6 times, but it is negative, so my result is negative 6. So just to reiterate, multiplying by the reciprocal of the coefficient of the variable will guarantee the variable is isolated, meaning I only have one left. Okay. Let's solve for t in this instance. I'm going to rewrite my problem to where it looks like I do have a coefficient versus a fraction. Negative t over 3 is the same thing as negative 1/3 t equals 5. Okay. My reciprocal of negative 1/3 is negative 3, so I'm going to multiply both sides by negative 3. The whole point of doing the reciprocal of negative 1/3 was to get it down to a single t equals negative 15. Let's try another problem with fractions here. 2/3 y equals 4. Now think about what the reciprocal of 2/3 is. And if I multiply both sides by its reciprocal, it is 3/2. So multiply 3/2 on both sides of the equation. I am left with y equals 12 over 2, which reduces down to 6. Let's try another problem. Now first, this is a little bit more complex, but we're going to combine similar terms first. So 5 plus 8 is 13, and we have 10x plus 20x plus minus 4x. They all have x in common, so they're all like terms. So I have 10x plus 20 is 30x minus 4x is 26x, and it's positive. Okay. Now I can isolate the variable. So I'm going to multiply both sides by 1 over 26. 1 over 26, leaving me with x equals 13 over 26, in other words, 1/2. Okay. And you can rewrite it from left to right if you want. Let's try another problem. 6x plus 5 equals negative 13. Well, I have constants, I have numbers on both sides of the equation. So I'm going to use my addition property of equality to isolate my variable. So first thing I want to do is subtract 5 from both sides to isolate my variables onto one side of my equation. Now I can use my multiplication property of equality to isolate down to 1x. So I multiply by 1/6. Multiply by 1/6. X equals a negative 18 over 6, and that's a negative 3. Here's an example where I have variable on one side, the left side of my equation, as well as the right side of the equation. I can use my addition property of equality to combine all of my variables onto one side, just like I can for my constants. So I'm going to add the opposite of positive 2x, which is negative 2x. And a negative 2x. I'm left with 3x equals 12. Using my multiplication property of equality, I can now multiply by 1/3 for each side of my equation. X equals 12 over 3, which equals 4. In this example, I have my variables on both sides of my equation. I have constants on both sides of the equations. So the first thing I want to do is figure out which side do I want my variables, which side I want my constants. And to me, it's a little easier to work with when I have my variables on the left-hand side, but sometimes it's easier to work with it on the right-hand side. In this example, I'm going to move the variables to the left, constants to the right. So the opposite of negative 2x is going to be a positive 2x. That's 5x minus 4 equals 6. Now I'm going to move my constant, which is negative 4, to the right. So the opposite of negative 4 is positive 4. Positive 4. I am left with 5x equals 10. And now I can use my multiplication property to multiply both sides by 1/5. 1/5. X equals 10/5. That equals 2. Now at this point, you might be asking yourself, well, this is good enough. We're working with all these problems, and it seems to be the same repetitive thing. Get all my variables together, get all my constants together. That's exactly what we're doing. Okay. But occasionally, we'll have to work with fractions. And there are two methods when we're working with fractions. The first method is you work with your fractions. Okay. 2/3 x plus 1/2 equals negative 3/4. So I'm going to move my 1/2. I'm going to add the opposite, which is a negative 1/2, to both sides using my addition property of equality. I have 2/3 x equals negative 3/4 plus negative 1/2. I need to find the common denominator. And my problem comes down to positive 2/3 x equals negative 5/4. I multiply both sides by the reciprocal of the coefficient, which is 3/2, and my solution is x equals negative 15/8. That's one method where we keep the fractions, we just work with the fractions. The second method is eliminating the fraction. The first thing I want to do is get rid of all the fractions. I have a 3 on the bottom on the denominator, my 2 on the denominator, and a 4 on the denominator. I find my lowest common denominator. This case, it's going to be 12. I multiply each side, but we have to keep in mind each side might include more than one term. On the left-hand side, I actually have 2 terms. I have to multiply both terms by the LCD. So the 2/3 x as well as the 1/2 on the left. On the right, I have to multiply that number by 12. Simplifying, now my problem comes down to 8x plus 6 equals negative 9. Then I continue the process. Subtract 6 from each side of the equation, leaving me with 8x equals negative 15. Now I use my multiplication property of equality, multiply both sides by 1/8, and I get the same result. X equals negative 15/8. But if you notice, I'm really kind of dividing by the constant. And that's because, if you remember, division is defined as multiplication of the reciprocal. So dividing the coefficient is the same thing. It's an acceptable way of reducing the variable down to 1. For example, 3x equals 18. I'm going to divide each side by 3, x equals 6. So whichever way that you prefer to do it, by multiplying by the reciprocal or just dividing by the coefficient, you choose which method you like to use. So until then, be seeing you.